Alright, this is the third question. It says calculate the number of moles in 4.A, that is A, 4.25 times 10 raised to the power of 21 molecules of oxygen, and B, 500 centimeter cube of carbon 4 oxide at standard temperature and pressure. So now at this point, let's go straight to it. For the A part, now the first thing that we are going to do is the formula for this. It is not the same with the other one, because if you look at this here, right, I don't know if you can still remember that of Avogadro's constant, but the formula is our number of moles is equal to number of molecules all over Avogadro's constant, which is 6.02 times 10 raised to the power of 23. Now this place that you see number of molecules, it could be a number of particles, it could be number of atoms, right? So it must not be molecules here, it can be particles, it can be both, the same formula here. Now at this point here, what we're going to have, we will now say that our number of moles will now be equal to, you see, number of particles has been given to us. They say that 4 point this is the number of what particles of oxygen. Now what we're going to do is it will be 4.25 times 10 raised to the power of 21 all over our Avogadro's constant, which is 6.02 times 10 raised to the power of 23. Now if you multiply, if you divide this properly, what you're going to obtain here, you're going to obtain 7.1 times 10 raised to the power minus 3. Now it is also in moles. Now that is your answer. You see, it is very simple, but the first thing is you must understand the formula. When you see they are talking about in terms of particles or in terms of molecules or in terms of atom, you have to use this particular formula in so that you can find the number of moles. Now the B part, let's go to the B part. If you look at the B part, it is almost similar to that of number 2. It says 500 centimeter cube of carbon dioxide at standard temperature and pressure. Now let's look at it again. What was the formula given to us? The formula given to us in this case, right, we are dealing with volume, as I said before. At standard temperature and pressure, the volume that we have, or the formula that we can use, it is number of number of moles is equal to volume all over 22,400 centimeter cube, or we can say that our number of particles, it will be equal to volume all over 2.4 dm cube, right? I think I introduced this I told you already for volume when it is at standard temperature and pressure in the class. But if you look at it now, we are not using this, which is in what, in dm cube. Why? Because the question, it is in what, in centimeter cube. So our number of moles will be, what is our volume given? The volume is 500. So 500 centimeter cube all over, what do we have as our standard volume here? It is 22,400, so which is also in centimeter cube. Down here, when you divide this, your answer, you're going to obtain 0.0022 moles, right? So that is your answer. Thank you very much. So if I can go again, or if I can go through what we talked about from the beginning. Now I believe there's no any problem, sir, from the beginning, but however, this is it. right? The first question is talking about this cryolite, which is the A part, and the B part is tetrahydrosulfate 6, and they said you should find the mass of 1 mole of the following, of the two of them, and this value has been given already to us. So that is just it.